session of this course on energy management through ICT. So last 4 days we have seen many issues and many energy management techniques and new energy technologies, and now we are in the last session. So we have with us Abhishek Syal. He did his engineering from BITS Pilani, and after that he did his masters from MIT Boston US, and now he is working with EMC Boston US as a senior market intelligence analyst, and he has even worked with BHEL, and I think he can give more in depth because I'm not the apt person to give you in depth what he did, so he will be just explaining his profile also. So he is giving a lecture on innovation in energy sector in US. So I think we can just have a comparison what is going on in India and what is in US, and I think you will be benefited from this lecture. And I hand over the session to Abhishek Syal.
Thanks, Shamika. Thanks everyone for the wonderful opportunity. And in case if there are questions, please do note them down and we can address them along the presentations or at the end. So about myself, I am done my master's from MIT and from Sloan School of Management. I also did a professional certificate in sustainable energy conversion and storage from Stanford University, as well as I did my engineering from BITS Pilani. Previously, I worked in energy research on the technical side at BHEL Corporate Research and Development, and I also was a co-inventor in 2 of their patent pending technologies. I also invented 2 other technologies on for visually challenged for map and diagram reader, and besides that I started my own nonprofit as well. Currently I'm working at EMC for their market intelligence. So my role is to identify the new trends in the market and how do they affect or change the market. So similarly, I thought that I would also highlight the trends in the energy market in the US and the current areas of research which you can then think about, which would be useful to you. So the agenda for our presentation today, I divided into 3 parts. First is kind of looking at what are the key energy innovation trends that are happening in the US, and then I also give you 2 or 3 examples regarding the same. Then the second part, I also share kind of like the events which I've been to or the events which are which you can follow, as well as some of the watch lists or kind of newsletters, updates, like very good website and resources that you can continue updating yourself if you're interested further on these topics. And I conclude with part 3 in kind of thinking about research areas for you that you can think about involving in some of your projects. So we start with the new energy trends, and one of the trends that I see happening in the US is kind of like secure cloud operated grid system. So what I mean by this is like it's kind of the grid is connected with a lot of industrial Internet of Things sensors. So you basically have sensors almost at every node of the grid or even more than that to build in redundancy, and these sensors are connected through Wi-Fi ideally or connected to the internet. So they give their data in real time about the network through the internet, and that data is collected at the back end, and some algorithms are run on the back end, and then there is grid optimization in real time in terms of whether you want to connect different parts of the grid or disconnect, to balance different loads, to kind of also have like remote operation. Like you can even disconnect certain parts for maintenance purposes, for example. It will also give you real-time status of the grid based on the sensors data, and you have like built-in algorithms that will detect for issues in the grid. So that's kind of happening, like cloud computing. Cloud computing is basically everything that all the data is going through the internet, which is called the cloud, and it's collected on the back end on your servers, and you can run like highly computationally intensive algorithms so that you can get that analysis done and real-time issues can pop up. Industrial Internet of Things is basically kind of sensors which are connected through the internet, which is very secure, so that other hackers, it's difficult for other hackers because, I mean, this is actually you're managing your very critical infrastructure. Therefore, cybersecurity is also an emerging component of this field. Where research is being done is kind of like cybersecurity as an important aspect, both for controlling or like remote operation for energy sources, as well as for controlling for your grid, so your distribution infrastructure, distribution and transmission infrastructure. One of the cool projects that has come from the MIT was kind of like looking at applying game theory principles to kind of cybersecurity. So what happens is in this project is kind of if hackers are kind of attacking the grid, so you apply game theory principles so as to minimize the losing the nodes to hackers. So that way, in real time, you do some analysis and run softwares so that only few parts of the nodes are effective and the rest of the grid is cut out from these affected nodes. So that's kind of game theory analysis, thinking about what's the hacker's next step or next 3 steps, and then back solving it to prevent, to actually connect or disconnect certain nodes. That's one of the important applications that was being done as a part of the project. The third interesting thing that is happening is kind of, which is related to more like cloud computing, is energy management as a service. What I mean by that is that energy management softwares and analytics and the results are available as a service-based model and not as like something that you need to install these softwares onto devices. So even if you have your home kind of a system and you want to look at it and see how much optimization you're doing for your, even like running the lights in this room, for example. So all the information regarding these lights and what the power usage, as well as when they were switched on, when they were switched off, during which days of the week they were switched on and they were switched off. Can I get some water, please? Including like when they were switched. Can you switch to the slide? If there are any questions at this point, I mean, I would love to take questions. Do you have any questions? So in energy management,
Sir,
yeah.
yes, actually there are 3 grids. When we talk about electrical grids, they are distributed in 3 parts, in 3 different parts. So the energy management is comprised of 3 separate grids, or it has been seen as a whole one grid, and then that energy management is done.
Right. So I do understand your point. The reason why you separate these grids out, because if one of these grids fail, you don't want the other grids to be affected. You don't want like a nationwide blackout. And that's why you do. And the reason they did like 3 grids and not like 10 grids was that you wanted economies of scale. These grids were designed in like 1800s or even like, thank you so much, like very far before the computers and internet were there. So they were designed keeping that viewpoint. Now in today's viewpoint, we also have a lot of like on-site generation. We also have like distributed like renewable energy sources which can connect to the grid. So from that standpoint, even let's say a energy source, traditional energy source such as hydropower plant goes off, you still have a lot of solar panels in the houses producing some energy to sustain themselves, and they can also feed to the grid. So from that standpoint, I mean, the market has changed in that. And when you talk about energy management, they don't speak about like load balancing of the between 2 grids. I mean, that's something which is very easy in the sense that it's just like you can think about it as 3 nodes, and you have to manage the supply and demand on these 3 nodes, which you can do very easily even by pen and paper. Whereas when you go down more deeper into like how these nodes are divided into subnodes, how these nodes go down, and now they're thinking about energy management in terms of like reducing the losses in transmission over long distances as well, because then you have long distances between the nodes and the subnodes and so on and so forth. So from that standpoint, energy management as a service is kind of like software which not only help you to manage your grid, that's one part of it, which some companies are doing, and also to think about like having remote control operations of the grid and the sources, but also energy management is done at the user end. So on your consumption side, like on your user, like for example, this institute would be a consumer. So to help this institute manage their energy needs, in both in terms of supply and demand, like you have some solar panels installed, so you would also supply or feed to the grid, and you would also have like battery backup. So once the battery backup is full and you are excess, let's suppose you have excess of it, then you would feed it back to the grid. So you can also set different controls in it. What's the optimum value that you should do it? And for example, let's say on the weekend, you can also set in, override the automatic settings. You can set in control like on weekends, any power that's produced by the SPV plant should go to the grid. It should not come to the institute. So you can set all these different controls. And that is something that you can do it on a website. And that website would interface with your smart kind of control system, and it would automatically update. Go there manually or do it. It would happen everything automatically connected through the internet. And by the way, the control system is new, so you have a good new control system on top of it, but your infrastructure can be old. So they're not changing the infrastructure, they're just putting a new controller on top of it, and this controller is being controlled by Wi-Fi or industrial internet, and from your website, from your home, you can change the settings. So that is like energy management as a service, that you can change it from remote operation, and you can just change the settings, or you can even automate that process. So to your point, this then goes to the next point, that it also helps to do preventive maintenance of kind of like energy sources and also like distribution and transmission infrastructure. What I mean by that is, once you have a lot of sensors which are embedded in these systems, or even let's say for this example, for the SPV plant, you have a smart controller. This smart controller would also be connected to a lot of sensors that are there on top of your traditional plant. And these sensors would continue to give you data. Now, machines typically don't just fail immediately. Like they start becoming more inefficient. There's more wear and tear over time, and then they start failing. So you can always see some characteristics such as like noise and vibration characteristics, for example, for a turbine. And you can see all of these characteristics in real time, as well as you can measure other environmental factors in real time, such as, for example, for a hydro turbine, if there's more salt concentration in the water, there's going to be more wear and tear on your turbine. So if you don't need to operate turbine at that point in time, it's better you just shut down, or you bring in backup water supply or some other way so that's to reduce wear and tear. Now, in case if it does wear and tear just happens, let's say each machine takes like 3 or 5 years, you have to maintain it. And the crew goes in, the field operator calls the crew, they go in, they maintain whatever turbine they have to do, they polish or whatever, or they install a new part. If it's broken, like if a blade is broken, you install a new blade or whatever they have to do, they do. But in this scenario, if you have a lot of sensors connected, you have information real time, you'll know how much is the wear and tear. You know how much it is happening in real time. And let's say for like this season, I suddenly get a lot of salty water and there's so much wear and tear that I know that by the next season, this turbine would not function. So instead of waiting the turbine to fail, GE could just go in and they could just replace the turbine and take the old turbine out. Or they could go in and they could prevent all whatever they want to do maintenance, and they could go in and they could do that. So the machine has not failed. So once they go in, they just have to replace the part of the machine or whatever it is, and that takes less amount of time rather than to number one, rather than to go back, that to let the machine fail, then you call someone and then the customer first get or the after sales service would come and then they would change and go back. So this takes a lot of time, whereas the new process would take a lot less time. So you have time savings, which means that your client or the energy power producing company is now more profitable. It also helps GE to save on capex and opex because now they don't have to maintain inventory. They have all the real-time data available, so they know how many machines are failing, how many machines are not failing. So they don't have to manage inventory. So even for them, it's a better choice. And in terms of opex, the maintenance cost is lower because simply you have more data and you can predict which machine will fail, which machine will not fail. So you can easily do that logistics and you don't need to have extra manpower on your hand just to cope with more sudden events. So you prevent the happening of black swan or sudden events because you have all these data in advance. So that's the important part, which is like really interesting about cloud computing and industrial Internet of Things, is that they're bringing in smart control systems on top of traditional infrastructure. Now, one example of this is kind of the Predix platform. It was been designed by GE, General Electric, and it's predicted to be around $6 billion in revenues for GE alone. It's kind of an open source system. I mean, it's open source. Like you could also go in and write an app for it. So you can write your own application on top of this platform. So it's open source. It's not closed source. And even because of open source, just for GE is $6 billion. So imagine for the whole world, it will be much more in terms of market size. And this is basically platform as a service. What this means is like it will give you basic code, and you can write your applications on top of this code. And these applications can be used to control your, let's say, SPV controllers remotely, for example. So once you install that software and once you have that smart controller, you could just do it based on, you could collect all the data, your machines will be connected to the internet, it will be a secure way to send your data. So you don't have to even worry about security. You just have to connect it through the internet after writing on top of this app and use their OS secure environment. And they also have like automation features, which means that they would automate your efficiency savings and control. So this is just an example. So based on Predix, GE, they also launched their startup as a separate company called Current. And they are basically doing a lot of intelligent environments, which is based on just the previous world trends which I discussed. This company itself alone is said to have around $1 billion in revenue. So you can imagine like how big this trend is. This is another company, which is a separate company called Gridpoint. And what they do is they kind of help in giving you like data-driven energy management solutions in basically collecting all your real-time data from all your sensors. So whether they're distributed over a grid, over machines, over any kind of power infrastructure, from the data, they'll just collect it. They'll give you real-time big data analytics. Big data, why big data? Because the amount of data sensors is very huge, and you don't need to save it. You just need to be able to analyze in real time pretty quickly. And big data technologies and the coding infrastructure is different because they use like NoSQL Hadoop, which is very different coding style and the different platform altogether as compared to like Java or C. So that has their own challenges, but they are providing kind of like integrated point of control to even monitor and manage your energy points. So even if you have like captive power plant, for example, for your office, let's say for your corporate, you have a captive power plant, they can come in, you put in sensors, and they can help you manage that entire captive power plant. The second big trend is around like smart buildings. So I split it into two parts. The first part being kind of net zero energy buildings and smart homes. What is basically meant by this is kind of you have on-site generation, which is like distributed energy sources. So traditionally, like for example, SPV power plants. But what is really interesting that's happening is not just on the SPV side, but also kind of what's happening on the policy side. So they give like very high incentives if you actually export your energy to the grid. The second thing that's really helpful is for this particular thing to work is they're developing very good storage systems. Like the major issue in any energy systems is kind of like energy storage, battery. I mean, it discharges very quickly. So you need to have better storage systems, energy storage systems, so that your distributed systems can have sufficiently large and long storage, and then be connected to the grid, and they can use that stored energy when there's a blackout or when the grid systems fail. Like when there's a very high snow, typically there is a blackout in the US in certain parts. So this is something which actually helps them in that stage to stay with power. And they also have like technologies like dual switch, in which you can kind of control whether you want to store or whether you want to export to the grid, or in some proportion thereof. So you can manage it through their smart control technology. In terms of like building and smart home automation, you have like a lot of temperature management devices. You also have we have like carbon monoxide sensors that's installed in the conference rooms. And carbon monoxide, and the way that's done intelligently is that the carbon monoxide sensor would sense the level of carbon monoxide in a room. Based on that, some calculations would be done automatically on the back end, and they would say like, okay, 6 people are sitting in the room versus like 8 people are sitting in the room. So they know how many people are sitting in the room. So on the back end side itself, based on that, they would change the thermostat setting according to the number of. So that is what is meant by like smart home or even like smart work, whatever, conference room automation. Is that?
Excuse me, sir. Sorry to interrupt. We are from DIT University, Dehradun.
Yep.
So during the, as you were saying, that storage of renewable energy that we are producing is one of the main aims of the smart homes. So could you please elaborate on what kind of battery system or storage units are being used in US, or what kind of research is being going on in as far as the storage units of the energy that we are producing from the renewable sources is concerned?
Sure. I actually have a slide on it, and I think it's point number 4, so it will be covered later.
Sure, sir. Sure, sir. Thank you.
Okay, perfect. Yeah. So what I mean by smart automation here is that it will detect the number of people sitting in the room, and based on the number of people, it would change the thermostat settings and other settings. So it's not just kind of looking at, okay, what's the temperature of this room? It would also look at the number of people, because how they think about it is like the number of people are also heat producing bodies. Like we have our own temperature, or we could be cool producing bodies if the temperature of the room is greater than our body temperature. So depending on what the difference is, and they can calculate in time roughly this is the setting that they should be at. And once the people exit the conference room, the carbon monoxide, they detect the differential kind of slope for the decline in the carbon monoxide levels, and based on that they turn the thermostat off. They also have integrated it with kind of scheduling systems. So for example, if I have a conference room that has my first meeting at 11 a.m. one day, so they would switch on the thermostat, let's say 15 minutes before the meeting, so that it's comfortable. But they would switch it off for the rest of the time. So that's kind of what's coming in kind of, again, automation. They also have like software analytics, and they basically have the same thing in terms of industrial Internet of Things, which is basically sensors connected through secure environment over the internet, as well as machine learning algorithms. So machine learning algorithms are kind of a software technology where you have algorithms which learn as they go. So they create you can think about it, they're like a small child and they learn about new things and as time passes on. So how do you use your infrastructure? They kind of learn over time. For example, like Google search is also, you can look at it, it's also some sort of a machine learning algorithm. It learns over time the search keywords and the results, and based on that, it would give you better results over time. So that's the kind of same sort of technology. These technologies also have a way where you can make sure that your employees are safe in the sense about fire or any circuit break or stuff like that, as well as kind of occupant satisfaction. The reason is because if you have sensors, ideally if you have sensors across your entire circuit, you would know if there's a higher increase of current in certain parts or overheating or stuff like that, and you could just shut that part out for a while or fuse it out some way. So you may not even fuse out that particular part, but you could fuse out some other part of the circuit which is connected to that circuit, so that number one, your infrastructure doesn't burn out, and number two, you prevent electrical fires, and number two is it's safer for everyone. Plus, it helps you save costs as the infrastructure is not burned. So some of the interesting work being done on the new startups. So I think give you examples of the market view here, just to be clear that this is something that's being done and this is being implemented. So I would talk more about the startups and kind of like interesting work being done by companies which is being implemented. And about these technologies, if you do want to go into depth, there is resources or patents or even kind of papers available, so you could definitely look that up as well. So one interesting company is kind of Link, and what they do is kind of they give you kind of real-time monitoring through kind of cloud-based systems. So basically, you put in, just like you have your what do you call it? You have your meter at home. So they would collect information from your meter, like at what time, how much you're using. For example, you can also put in additional sensors if you have. Thermostats can be looked as upon a sensor. So all the US homes that generally have like centrally air conditioned. They also have like, so Boston currently has like two systems. One is like water-based heating system or cooling system. So water is heated with electricity or gas, and then it's just circulated through the building. The heated water is circulated, and that's where you create heat. The other system is electric system, which is kind of like you have the electric coils running from at the bottom of the room, not on the floor, on the sides of the wall and the floor, and your current basically runs through it, and there's heat produced. So based on your usage and kind of how you use it, what time in the day, and they would give you kind of control of your all systems at home. So from your Wi-Fi on your phone, on your app, you could even switch it off. So for example, let's say I am in a hurry, and actually half of the time I forgot to turn off the thermostat when I leave home to school or to my work, and I just never had any way to kind of turn it off. So if it's like a thermostat that's connected through Wi-Fi, then on my app, I can just log in. I could just say, oh, I forgot it, or didn't I forget it? I can check the status of the thermometer. I can turn it on or off in case nobody is home. So even like that simple function helps you save a lot of energy. And over time, this app would learn that I turn off thermometers at 9 a.m. Monday to Friday. So if I didn't turn off, and if the status is on, it will give me a pop-up notification and ask me whether I want to turn it off. That's like kind of a machine learning automated system. This is again an example of the thermostat, which is exactly the same functionality. This also has much more different functionality. It's called Nest. It was actually acquired by Google, and they actually are trying to integrate it in smart home. And what it does is it also kind of does a learning about day-based preferences and even kind of month-based preferences throughout the year. So like in summer months, it will be totally shut off because it will be too hot, or it will be actually cooler, rather. They will turn the cool if you have a dual system, that is. So that's why it would learn about your system. So the best part about this thermostat is that this thermostat can just integrate with your systems which are like 100 years old or even like 50 years old. So you don't need to buy new capital. You don't need to have like capex, or capital expenditure to buy new heating or cooling systems. It would just directly integrate with your Honeywell systems or any other systems that you have. So that's the kind of approach that they're taking, is to make current infrastructure more efficient. Um, in the UK, there's another startup which is actually even much, I believe it's much better technology than Nest. And what it does, it divides your home into zones. So like kitchen would be one zone, for example, your bathrooms would be another zone, and your rooms could be another zone, your living room or drawing room could be another zone. And based on zone, it always provides zone-based management, not just for the total house, but for the zone-based. A second part of this trend of our smart home and smart buildings is also kind of integrated energy districts. What is happening is, now people realize that different buildings sometimes end up being still inefficient. So some buildings have the need that their heating systems are just not that good, and the other buildings have like latest state-of-the-art heating systems, and they produce extra heat. So technically, currently, this heat is being wasted into the environment. What you could do is you could link these sources in some way, and you could transfer the heat, some part of the heat, to the other building and charge the other building for it. So for the other building, it's good because they don't need to rip out their existing infrastructure, but they can just buy that differential amount from the other building, which produces more heat. So an example of it, actually, it's from Canada, and it's a building at University of British Columbia. They actually capture the waste heat from a research institute which is located adjacent to it. It's kind of like a primer to development of smart cities. So they think about it like, and it goes across property lines. So it's not just one building. So it's like you think about energy connectedness amongst different types of properties as well. And this is actually done by United Nations Environment Program, like Environment for Development. They came up with district energy in cities. It's a very growing trend. This is the kind of overview of what is district energy. And I mean, this is something that you can on their website. But this is what they're doing, is kind of like, they don't want you to rip out and waste, because if you rip out your previous existing system which is working, it would create a lot of waste as well. So they want you to be more efficient on the existing system. They want to connect existing system with new systems and ensure that the distribution internally or locally is also done very nice. The other part of the district energy is like, sometimes, many a time, people have some extra capacity on their on-site generation. And if you think about it, if they just export it directly to the grid, I mean, the grid is pretty big. And if you're exporting a very small amount, a lot of it would be just wasted as heat or in transmission and distribution. Whereas if you connect that extra amount and you still give that incentive to the person who's producing it, but you connect that extra amount to, like, say, next door neighbor, you would not waste so much of electricity or energy in like distribution and transmission. So at the end of the day, you would end up being more efficient even from a grid scale level if you have this better optimization at the local level. So this is what it's basically about. There are different sort of energy sources, and they are thinking about this. And this is a concept map. The third big trend that's happening is kind of like the mainstreaming of nuclear energy. So nuclear energy reactors were built in like 50s and 60s. The designs have remained pretty much the same. The industry is just the same, and now they are disrupting the industry with new designs and also new materials. So how to make nuclear reactors more better, much more smaller. So even in case if they break, their effect would not be that big in terms of the land size. So if you have smaller reactors, you have basically smaller chances with smaller explosions, apparently, but they're trying to make it even more safer so that this is not affecting. The reason why nuclear energy is so important is because it's a very high density energy source as compared to solar power as well as other energy sources. Like nuclear energy is like way ahead. Um, I could probably just check back with them with kind of what's the energy density, but I can definitely add that as an appendix later on. The other thing that is happening is like even the venture capitalists have started investing in nuclear startups. They don't see it as kind of a research only. They see it more from a market view, and they see it's something that's going to come and something that is really going to happen. So venture capitalists, they're kind of like a very stringent investors. They look for a very high return, and they look for like new industries or disruptive research which has market applications. So if they're investing, it's pretty sure that it's going to come. It's just they have been very successful in bringing new things to market. Like Microsoft and even Bloomberg, they also raised capital from venture capitalists initially when they were small. So one of the startups, and I actually know the CEO of this startup, she's at MIT. She did a PhD in nuclear engineering. She and her teammates have launched Transatomic. I mean, Leslie is her name. Leslie and Mark, they are the co-founders, and they have launched this Transatomic. And what they're doing is they're eliminating waste. So a lot of nuclear waste is radioactive, which is again, I mean, you have to manage it and to ensure that it's right. So in US, what they do is they have like a huge mountain in the middle of the desert, and they go and dump the nuclear waste. And it's like, and they have a huge like kind of a thing. It's like a no entry zone. I mean, unless until you want to die, but kind of like you have it, and so, but it creates a lot of radioactive waste and dump, and it's like you're wasting a lot of land. So what they're thinking about is kind of like they're eliminating the nuclear waste, as well as thinking about how they can probably reuse it or consume this waste into a nuclear reactor, and then create energy from this waste as well, and then create waste which is not radioactive, which is safe for the environment. So that's like a kind of process that they've done. They've actually done successful research on this. They have also raised money from the VCs, and they basically they are going to be one of the big players. That is my viewpoint. The other company, and this came out of Y Combinator. So Y Combinator is kind of like, it's like the MIT and Harvard of startup accelerators. So for startup institutes, it's like one of the best. And U-Power Technologies, they're basically thinking about having like a megawatt scale atomic generator, which basically means having like very small atomic generators. So traditionally in nuclear power plants, you typically have very big generators because you require a lot of safety, you require additional layers and to ensure that nothing goes wrong, as well as it makes more sense. It's a very highly captive kind of a thing because you create radioactive waste, so you just wanted one big power plant so that, and thinking about traditional infrastructure, you just have like huge grid to feed, so that's why you wanted huge nuclear power plants. Whereas now, in terms of philosophy of how we distribute electricity and consume it, it's more becoming like localized, distributed, more efficient. So from that standpoint, the startup is thinking about like how do we create smaller, safer nuclear reactors that could be installed and could be distributed across the country. And the fourth biggest trend is kind of like better batteries, and one thing also is like better electric cars. Is electric cars are also, they take in a lot of electricity and they run pretty daily. Transportation is very big requirement. Trains. So kind of what research is going, and in fact in 2013, Time actually put in David, I think, put in like an MIT professor as #1 on the Times 100 influential list, who actually researched on like liquid metal batteries. So that's to your answer to the question. It's like one kind of new battery systems that is coming is like liquid metal batteries. They operate at typically very high temp. I mean, he has made it a way so that they can operate at 400 to 500 degrees Celsius in his research. And the metal stays liquid at that point, whereas if you know that metals have like a really, really high melting point. So he has made special alloys which melt at a lower temperature so that you could have liquid metal batteries which can operate. The other ones are typically lithium ion, and they are trying to make lithium ion more efficient, more energy density, and last longer. So that's the two kind of research areas that I know of. There might be more, but what they're doing right now is kind of using batteries backups and using these SPV panels and other sources as backup for like the power grid, instead of building like on-demand power plants which are just switched on or switched off from the energy needs. So as you know, like during the months of summer, you have a lot of energy requirement. So during that time, they would switch on these power plants, probably run them for 2-3 months, and then turn it off. And for the rest of the year, they are just not there. I mean, it's a very efficient and inefficient and expensive way, because you have to manage all the equipment. You have to ensure that things are running and things are safe. Because if the things are not running most of the time, I mean, things get jammed and rusted pretty much more quickly than when things are running. So to that, the utility industries or the power producers are trying to basically use batteries as a backup option. The other ones are kind of like electric cars, which are using batteries which are now cheaper and with more efficient designs, with higher density storage, to kind of make sure that they have you can drive for a longer period of time, as well as also have recharged based on other mechanical characteristics. You can recharge as well. So one example that I know of is like when you brake, that brake energy dissipation can be used to recharge your battery. That can be used to propel you forward. So that's something one example that I do remember. From a standpoint, as I was developing this presentation, I was just thinking, and to me, what seemed to be the future is kind of like self-driving cars. And if you have like self-driving electric cars, you could think about it that they are like a mobile energy grid. They're basically energy sources or energy storage, batteries that are moving around, and they're just transporting people and things. So I think there would be some very interesting ideas on like, okay, we're not just transporting people and things, but they could also transport energy in future. That is something which I'm just thinking right now, but that's something that just came up as I was developing this presentation. So I thought I could share it with all of you. So one example of being like doing better lithium-ion batteries is kind of this Sunverge startup that's doing. They integrate directly with the SPV panels, and they basically have more smaller form factor, which means that they're smaller than the traditional batteries. They're more higher energy density as well. More system intelligence would mean kind of like having more management tools or energy management as a service tools through the cloud, like through your website or through your mobile app. You could just manage it in a much smarter way. The other one is A123 Systems. This is the one that has been actually done by the MIT, if I'm not wrong. And what they do is some of the batteries are liquid metal ion batteries, and they do in two ways. Number one is like transportation systems. So they're working with like Prius as well, to kind of build some, as well as Porsche, to kind of build some of the batteries for the cars. They're also thinking about building power backup batteries for like captive power plants. So all you have like power plants which are supporting only another like factory. So those are like captive power plants, so they're building power backup for them. And the fifth is the biggest trend that I see is kind of like inducing energy conscious user behavior. This is a very interesting trend, and what they're doing is they're applying the behavioral psychology principles to basically induce more energy conscious behavior amongst the users or amongst human beings. So what is happening is that they would give you kind of like a bill like this. If you can zoom in, do you have someone to control the camera? Like you can zoom in or you can show this. So this is like a bill which I mean kind of a thing which I got, and in this, as you can see on top, you have kind of like month and usage. Now this will also give me month and usage as compared to my neighbors. I mean, you can see some 2-3 different lines. So the blue line, the dark blue line is my monthly usage along these months, and the other line is kind of like the average neighbor usage. So for example, and this is by the company O-Power, and they actually give these kind of like analytic solution, as well as they give me kind of recommendations on how much I could save if I do some of these steps. And so they actually make you more informed as a user, and they help drive kind of the behavior for the users. So users become more energy conscious, and hence you save more energy as a society. This is a very up and coming trend. There's a company called O-Power. It has literally grown from like 0 to millions, like literally in the span of a year or so. And it provides all these energy management tools that you could have on your app. And their business model is that they would sell this analytics and software to utilities. The utilities could provide like these sort of bills to their customers. So my power company that provides electricity to me is Eversource, and O-Power actually sells to Eversource, so they can send me this kind of like it's not a bill, but they can send me this kind of a tip-based guidance, and then they would, which can help me manage my, or become more energy conscious. So how does it help the utilities? I mean, technically, if you're using lesser energy, it's not helping the utilities. But the thing is, it also helps them to stabilize demand and predict demand. So for them, the most important thing is predicting the demand of the energy demand and having it lesser fluctuating as possible. Because the more fluctuating the energy demand is, the more you can think about it, the more capacity of power plants you need to keep. So you might not be running on the operating efficiency capacity of your power plants or sources, but you might be running even half of that operating efficiency, and your profitability is low. Whereas if you have these kind of systems, and if users are kind of becoming more conscious, and you have a more stable and predictable demand, you will end up running your power producing equipment at closer to operating efficiency of the power plant, and therefore you would have better revenue management, as well as you would have more profitability. So that's why it's really important for the utilities, and that's why they really want it, and that's like the selling point, these sort of softwares. Just as another example, like O-Power, these are the services that they provide. They provide energy efficiency, demand response, digital engagement. Digital engagement is kind of the bill. So this is the same example that kind of like the same example kind of showed. This would also tell you how much more efficient you have become since last year. So it would give you feedback to the user about this. The other company that's doing is kind of like Simple Energy. It's basically doing something very similar. So, I mean, they would have their own proprietary algorithms and the backend, but at the end, they basically convey the same. They have the same business model as kind of O-Power. So they provide suggestions, tips, guidance to customers. They sell to utilities or the power producers, which will then provide these kind of features to the customers. So these are the kind of trends that I see that are happening that are very kind of important. Do you have any questions on this before we move on? Perfect. The next part, I thought of sharing with you some of the events that I've been to, as well as the watch list. Yeah.
Is there any power?
Excuse me, sir. Excuse me, sir.
Yep.
I'm from DIT University.
Hello. Yeah.
Hello, I'm from DIT University. I have one question about district distribution.
Okay.
What are the new technologies has been now used in case of incorporating those energy sources from different frequency and voltages in that grid? What are the new technologies that have been used
Right.
to incorporate?
But I'm. I think you would have transformer for that, right? If you have different voltages, you would basically have transformers.
New technologies. Yeah.
What are the new technologies has been incorporated whenever there are different kind of voltage sources and frequencies, but when they are connecting in that grid, district distribution grid?
Right. So in that, the new source, the new things. So I mean, I think what you're asking is kind of the hardware question. And just to be clear, in terms of the research which I see, which is going in terms of kind of where things are happening, I don't see, I'm not sure if I see many kind of new hardware devices, but to the point, to the slide in which I say like the secure cloud operated grid, they are more focused on using available hardware to give better output. And when you think about, okay, different frequencies, okay, for example, like your wind turbines, for let's say you're putting in more wind turbines, they're already designed to have all of these issues taken care of. So even for like SPV plant, for wind turbines and other even biogas digesters and electricity generated from them, as far as I understand, they already have done that technology integration part to have the output out in the frequency and voltage that you require. So the challenge here is not the hardware technology anymore or the optimization of it. The challenge here is in terms of not even integration with the grid. Like they have transformers and switches and whatnot to do it. The challenge here is in how to, you have 10,000 new sources suddenly connected to the grid. How do you manage these sources? So they are in the stage where like a lot of houses have kind of solar SPV. They also have battery backup systems. And the challenge is not connecting to the grid because that technology is available. The challenge is kind of having like 10,000 or different capacities of SPV power generating units connected to the grid. So how do you make sure that you are being efficient in terms of managing the extra power generated through this SPV, and how do you localize that power so that you don't have these losses over transmission and distribution infrastructure? That's the problem that they're focusing at. To your question, I can double check on what research is being done. What research is being done, to my knowledge, on the hardware side is kind of including 3D printing of materials. So instead of having kind of parts which are using CNC and lathe machine, on the mechanical end of it, they are now thinking about how do we use a 3D printer with metals to actually print out a complicated blade shape, or print out a very different shape with a lot of, let's say, fins or a lot of other additional things which are just not possible with CNC machines or other manufacturing techniques. So that is what they are also doing research on the hardware side, but that's more to do with metals, more to do with like manufacturing processes. In terms of electronics, most of the integration and most of the functionality of the switches, like a two-way switch or a dual switch, that's available in the market, and that's been there for some quite time. But I will double check on that as well.
So regarding the power exchange in US, we do have power in India. Do have power exchange in India,
Yeah.
which works on 15-minute basis. Whereas in US, I think it is 1 hourly basis. And with so many distribution companies over there, so many suppliers of electricity.
Right.
So how do they manage to get that power exchange to them? Because they might be getting power from some side. They are providing power to some side. So is there?
Yes. I need to check on that answer. I'm not sure. And I don't want to give you a wrong answer, but I'll double check. What I think is, okay, so I don't know what's there, but I think what they're transitioning to is kind of having, I mean, they have had that infrastructure for a long, long time, and they've maintained it pretty well. So, and they have built-in systems again, which is that you can just lock in and connect. Now, if you think about distributed sources such as like SPV, almost every houses are incentivized to have SPV. Like in Massachusetts, which is like a state, they have a program where they will subsidize your SPV installation. Then they will give you better rate than even like a high that you pay for your per unit. So you want to keep all your roofs and you have that installation done. And then now if you're connecting, let's say a lot of houses are putting on this SPV, a lot of these SPVs connected to the grid, you can think about having like 10,000 houses connecting in let's say over 1 month, connecting to the grid, and that's kind of like also an independent power producer with a very distributed way. So to me, it seems like that's kind of like plug and play systems that they don't really have to worry much about it. Like they have that thing sorted out. I can check what do they use for that and what are the technologies that they have done for that. But that is something which is like readily available for them, and they don't think and like that's not the research focus, so that's not where they are focusing. But it could be helpful for the Indian market. So I'll add into it. I'll add new slides and I'll send it across to Shamika, and then she can just send it across. I think. And what I was thinking, where I was coming from, is kind of like what's happening there, like what's the cutting edge there, and from a market standpoint. But however, yes, I mean that what's available there could be cutting edge for us. So I'll definitely add on to it. And if you have more topics that you would want me to add on resources, like I can think about adding it on and then giving you that slide or whatever, at least the materials available. So please let me know. So some of the events where I've gone to is actually MIT Clean Energy Prize and MIT Energy Conference. They are pretty big. The MIT Clean Energy Prize is actually kind of supported or sponsored by Eversource, and Eversource gives like $300,000 for the winner, and they also give more other cash prizes. So it's one of the biggest competitions in the US. Like it's much bigger than MIT 100K business plan competitions. And actually, in Clean Energy Prize, we get to see what is the latest and greatest that's happening, not only at MIT but across US, because we typically get competitors across US. So Transatomic Power, they actually were there in, I believe, in 2014 or 2015 Clean Energy Prize, like a year before they were there presenting. It was very interesting to get to know. And they look at both like energy management, energy efficiency. So a lot of these trends are actually derived from my interactions from Clean Energy Prize competition, as well as Energy Conference, what they're thinking about. There are other conferences that you can just click at. I've given the URL, so you can go through them and you can sign on their newsletter. They would probably have some resources available as well, so you would get to know about other research as well. Some of the watch lists and blogs where you can get to know about what's happening in the US, and you can keep yourselves updated. Even after this lecture, you could probably even find more information that I've conveyed. And I actually like the resources because, especially if you go to this NREL, that's like a government initiative for like renewable energy. So there you would get like the latest research that's happening in the US, what kind of projects they're doing, both technology-wise as well. The other institute that's like really, really good besides MIT in clean energy is actually Berkeley University in the US. So you should definitely look up on the, this is one blog that I just found which is interesting, but you should definitely follow the research of scientists or professors at Berkeley University for the clean energy, because they are typically much more advanced as well. I mean, it's like the known college for clean energy. So the research trends that I think are going to come to India as well, and in fact there are some Indian startups actually, as I speak, about cloud computing and also analytics. There's a startup called Bijli. Their actually offices are based in Bangalore, and they have clients are in Canada, UK, and US, and they want to enter the Indian market. So these trends are going to come to India. They are there in US, and I think that is something that we as teachers, as we think about your research or projects, you should also think about some of the practical applications standpoint that you can derive from these topics. So Industrial Internet of Things is nothing but like smart sensors to ensure you have connectedness amongst various components of whether your grid, power producers, distribution and transmission, and so on and so forth. So you think about connectedness, and not just from the producing end, but also from distribution and transmission, and also from the usage end, such as your homes and buildings. So it's like an end-to-end connectedness that you can think about while you're doing some projects. The second thing is cloud computing. Why is this important? Is because it provides you like a real-time remote operational facility. So even if you are on a weekend and let's say you forgot to switch the lights off in your office, you can just do it from your home, and that will help save energy and help in better management of energy. The third is big data. So as you have Industrial Internet of Things and cloud computing, you get a lot of data that's available to you. So you need a different software or a coding platform that's basically like Hadoop or NoSQL, or even GE's Predix platform, which is open source. So you should definitely check out at least Predix, I would say. And I believe that you can easily do some of your projects on Predix. It's a very nice, and I think it's a very market forward-looking thing to do for your students as well. Fourth is predictive analytics. Predictive analytics is kind of like smart algorithms or machine learning algorithms that you can build in. They can collect all the data or the big data from the sensors in real time. On cloud computing infrastructure, they can analyze that data, and then they can give you the results. From the results, you could even derive recommendations, which can help you to have like preventive maintenance of your machines, or even preventive maintenance of your grid, like where the kind of wires are not, where the wires are being affected. For example, there's a storm and the wires were affected, so you could get that data as well as in real time, rather than having the complete wire cut off and then you realize, oh yeah, that area was affected by a storm and we should probably have a new wire. So from that standpoint, preventive maintenance is like pretty big. The fifth one is kind of machine learning. This again feeds back into some sort of predictive analytics. So it's kind of like a base level. But I believe what machine learning does is kind of having like two things: personalization of automation, and second is also localization of automation. So personalization of automation, I mean by having kind of smart control systems, whether it's in your room, whether it's in the grid. So you can also think about that. The localization part is more to do with grid. So wherever district energy hubs are there, or wherever you want to there's more certainly surge in demand from a particular locality, you could have this machine learning algorithms take care of that localization of surge in demand. I mean, the surge in demand could happen, for example, just because of events. Like there's a huge event, then they have huge lighting. Suddenly, you have a big wedding. Your lighting turned on. I'm just kidding. And suddenly you have 10 weddings in one place. But that's what I mean is like kind of your demand could go up and down. I mean, this is a light example, but that's kind of where it could really help to manage that kind of information as well, if the systems are connected with other systems or information, even from like scheduling or booking of the venues. Then you also have like kind of like behavioral psychology applications. This is something that you can think about interdisciplinary research, not just behavioral psychology, but you can also think about game theory and how to apply game theory in kind of cybersecurity to induce user behavior, to prevent people from hacking into the systems, whether they are grid-based systems or whether they are kind of other your very important power-producing infrastructure systems. So these are the research trends which I see which are coming to the market, which have already come, and more applications are going to be based on it. And I would love to have your questions.